Dr. Lutzmeli, Associate Professor in the Department of Computer Science and Engineering. I am going to take scheduling in operating system, the subject operating system. The subject code is CS8493. So to understand the basic concept of scheduling in Linux, scheduling the job of allocating CPU time to different tasks within an operating system. While scheduling is normally thought of as a running and interrupting process, scheduling also includes the running of the various kernel tasks. So running kernel task encompasses both the tasks that are requested by the process and the tasks that execute internally on behalf of a device driver. So it is a new scheduling algorithm. So preemptive, priority based and known as O of 1, order of 1. So the real time range nice value has the challenges with the interactive performance. So it is introduced with the completely fair schedulers. So CFS eliminates traditional common idea of time slicing mechanism. Instead of all tasks allocated portion of processor time, CFS calculates how long a process should run as a function of total number of tasks. Nrunnable task means gets n by n of processor time. Then weights each task with its nice value. So higher weight, higher priority. Smaller nice value will be higher weight and higher. And each task run with the time proportional to task weight divided by the total weight of all runnable tasks. Configurable variable target latency is desired interval during which each task should run at least once. So consider a simple case of two runnable tasks with equal weight and target latency of 10 milliseconds. Each then runs for 5 milliseconds. If 10 runnable tasks each run for 1 millisecond, so minimum granularity ensures each run has a reasonable amount of. So kernel synchronization, it can occur in two ways. A running program may request an operating system service either explicitly via a system call or when a page fault occurs. The device driver may deliver a hardware interrupt that causes a CPU to start executing a kernel defined handler for that interrupt. Kernel synchronization requires a framework that would allow the user kernel's critical section to run without interruption by another section. It uses the techniques to protect critical section. Normal kernel code is non-preemptible. When a time interrupt is received while a process is executing a kernel system service routine, the kernel need a reschedule flag is set so that the scheduler will run once the system call has completed and the control is about to be returned to user mode. The second is applying an interrupt service, interrupt hardware control. It provides spin locks, semaphores and reader-writer versions of both. Behavior modified if on single processor or multiprocessor. Single processor disable kernel preemption or occurs spin lock. A single processor enables kernel preemption, releases spin lock. So possible questions are explain in detail about schedule